introduce and tell the people about the. Martin, you got those. Martin has got some sheets. Just write your name and email address on it. Please, everybody, just take one ticket, and we'll raffle out. Where is it? A subscription for, basically 2 subscriptions for the Entwickler kiosk, brought to you by the S&S Media Support. Perfect. Then there are some partner programs. There's a 50% discount for the API Summit in Munich. With this promotion code as well, there is a discount, 25% off for the Socrates Days Linz in November, basically. And I want to thank our sponsors, Oracle, who make these events possible, as well as the SMAC, who's hosting this event today. So thanks a lot for the support. And that's basically all I have to say. Enjoy the evening, and please welcome Josh.
Thank you, buddy. Appreciate it. Yeah, okay, trade.
You okay?
Marco, Polo, test, test.
Seems to work. And just put it somewhere.
It's caught on itself. All right, look at that.
Perfect. And for the rest, just put the stuff in there and look at it afterwards.
There's going to be a raffle. I am connected. All right. Awkward. That was Can you grab that? Yeah, thanks. HDMI cable down there.
There you go. Where's your HDMI?
Over here, bud. Thank you. So, okay. Woo. Whoops. Wow. Normally, when I connect to a screen, it's at a much lower resolution than the native resolution of my laptop. But you brought your A game today. All right. Right on. So, first things first. Well, thanks for all being here. I appreciate that. I work at Pivotal, and at Pivotal, we're hiring. So if you are interested in working with the best, well, we're not the worst, so you might consider us. Lots of interesting people there at Pivotal, the big old Pivotal Ranch. Would love to have some help. It's a nice organization. There's headcount for some of these projects right now, some later. I don't know. It's kind of up in the air. Just check that website. Thanks for coming to this. We're going to go through a lot of stuff today, my friends. We have a lot of things we need to cover. Oh, yeah. All right. We have a lot of stuff that we need to cover, a lot of things that we need to go over. So I want to establish this up front, that there's a GitHub repository there for your own edification, for your own reference for later. It has the code that we're going to cover in this brief time together here. And if you have questions, comments, feedback, whatever, don't hesitate to reach out to me. I am here for you. I'm at your service. If you should have questions, don't hesitate to reach out to me on Twitter. How many of you, by show of hands, are on Twitter? I'm just curious. Twitter. 2018. Twitter. All right, the rest of you. What about email? How many of you are using email? Email. Anybody? Is anybody using email? No. Good. Moving on. My name is Josh Long. I'm a Spring Developer Advocate here on the Spring team. I'm an open source engineer and a contributor. I've got the dubious distinction of being the number one top ranked, most prolific, most highly lauded, most acclaimed, most visible contributor of bugs, but still number one. Number one. Christoph can attest to that. You know, more bugs per commit than any other engineer on the Spring team. It's not the best record, but it's a record. There's that. 10 years of just bugs, just all the time. I basically keep them all very busy. And as part of what I've done, as part of what I do is in my role as a developer advocate, I spend my time trying to help people build better software in terms of the Spring and the Java ecosystems. And as part of that, I do training videos. So I've done a number of different training videos, some of which you may see on that particular screen over there, since I'm blocking this one, including videos on how to do applied continuous delivery with Marcin Grzesiak, Cloud Native Java. There's actually a version of this video there as well, building REST APIs, Cloud Foundry, I mean, all sorts of good stuff there. These are often as not with people that are smarter than I am. So for example, Marcin Grzesiak is the lead of Spring Cloud Pipelines and Spring Cloud Contract. Josh McKenty is the creator of OpenStack and one of our deeply talented professionals working on Cloud Foundry over at Pivotal. And of course, Phil Webb is the co-founder, the inimitable, the amazing, and the unforgettable co-founder of Spring Boot, Phil Webb. So lots of really interesting people there. And also, I write books, and so I just finished my 5th book. This book is called Cloud Native Java. It's all about how to build applications that survive and thrive on the cloud, in terms of Spring Boot, Spring Cloud, and Cloud Foundry. And this book, it took a little longer than that I'm a little comfortable admitting. It took a little longer than I thought it was going to take. My co-author and I, Kenny Bastani and I, we worked hard, we worked diligently on this book. And we thought, what with software estimates being a solved problem, we thought, that's a joke, friends. It's a terrible joke. Software estimates are not solved. Anyway, moving on. We thought, with software estimates being a solved problem, we thought we would be done 6 months. We estimated 6 months in and out, no problem. We'd be able to write a book, a comprehensive book that covered the essence of all of these different technologies and did so in a comprehensive way in 6 months. And you can blame us. You can say that it's ambitious. It's an ambitious goal to write a book that covers the essence of Spring Boot, which by itself is moving a mile a minute, and Spring Cloud, which is a huge ocean that's also moving a mile a minute, and then Cloud Foundry, which is a whole ecosystem as well, all moving miles and miles a minute. So we thought, surely we could get that done. No problem. 6 months. No problem at all. They'll sit still, and we'll just write about it right now, what they are, and we'll get it done. And it took a little longer, okay? It did. It took a little longer than 6 months. I wish it had been, 6 months. But I don't want to air my dirty laundry here. In English you say, air your dirty laundry. That means talk about personal stuff. I don't want to air my dirty laundry here, but I feel like we're friends. We've known each other for, 3-4 minutes now. So we can talk about this stuff. I don't want to air my dirty laundry here, but I'm going to go ahead and just say it. I'll just say it. My co-author and I, we worked together. We were a team. And as a team, we had some trouble with our publisher, O'Reilly. Okay, I'll just go ahead and say it. O'Reilly, we went back and forth. We went back and forth over a little bit of time. It took a little longer than 6 months. We had long debates. Let's just say debates. Okay. Oh no. You know what? There were arguments. Really. There were rancorous, arduous, argumentative debates. That it took a little longer. If we didn't have these debates, it wouldn't have taken as long as it did. It took a little longer than 6 months. Okay, it took 2 years. It took 2 years to get this book done. And the reason is because O'Reilly and we, the author team, we couldn't arrive, we couldn't settle on the animal for the cover. And so anybody who knows anything about O'Reilly books knows that it doesn't matter what you write about. Nobody cares. It's everything to do with the animal on the cover. So we spent an extra 18 months going back and forth trying to arrive at the right animal for the cover. And we eventually settled upon the blue-eared kingfisher. The blue-eared kingfisher is a bird from the Indonesian Java Islands. It's indigenous, or as we'd say in English, native to the Java Islands. And birds fly, yes, through the clouds. So it's a bird that flies through the clouds that is native to Java. It's a cloud-native Java bird. It's a bird. It's a bird. Never mind. It'll come. Give it time. So there's that. And of course, I work at Pivotal, along with my friend Christoph here and Jürgen, who just left because he has more important things to do. And at Pivotal, we have a lot of great open source software. You may recognize some of the software on this slide. We love open source. We care very much about open source. But let's be very, very clear. At the end of the day, ultimately, it is not the thing that drives us. It is not the thing that motivates us. It's not the reason that people like myself spring out of bed. What we care about, first and foremost, ultimately, is building better software faster and to help customers and community members and organizations build better software faster. We want to see them cut down that cycle time from concept all the way to customer. How quickly can they take an idea and see it delivered into production? And we know that a lot of organizations struggle with this. They know that they need to go faster, but they struggle with how. They look for ways to go faster, but they struggle with how. And it's very easy to say, oh, well, look at those startups. Those startups are succeeding. They're going quickly. They're able to go quickly, and it's because they're small. A startup is, by definition, small. So surely the secret is the size of the organization. And really, these larger companies can't be expected to scale to be able to deliver software that quickly. How can we compete with the likes of whatever, Uber for cats? This idea, this sense it's close, but it's misguided. It ignores that there are very large companies out there that are also delivering value to customers very quickly. Look at Amazon, look at Netflix, look at Twitter, look at eBay, look at Google. These companies are delivering software very, very quickly, as competitively as any startup out there. But they are not, by any stretch, small organizations. So what's their secret? Well, I think size is a good start. You're kind of on the right path there, but you're missing the real important bit here. It's the size of the team working on the software itself. It's not the organization proper. It's the size of the team working on any piece of software. And this is a simple insight. The smaller the team, the more readily that team is able to deliver value into production. They're able to cycle. And a lot of organizations have seen this effect, right? These large organizations, they understand the smaller the team, faster they can go. This is not new. It's not a controversial insight. It's not a new insight by any stretch. Mel Conway in the 1970s, he understood, he seized upon this insight. He said, software is a mirror image of the communication patterns of the organization that builds it. Software is a mirror image of the communication patterns of the organization that builds it. Put another way, if you have 4 different teams working on a compiler, you'll have a 4-pass compiler. Put another way, if your organization is dysfunctional, then the software that organization builds and the modules and the things that organization builds will be dysfunctional in its relationship with each other. It'll reflect that dysfunction. Put another way, crap in, crap out. You want to fix your software, you fix your organization. Very, very simple. And they've done countless studies to confirm this effect over the intervening, and again, it's important to stress this, decades. This is not a new idea by any stretch. Remember, 1970s. They've done studies to confirm this effect over the intervening decades. They looked at open source software and they compared it to something of analogous form and function in the proprietary world. Imagine you had the opportunity here, and I'm using these giant, glaring blisteringly ironic air quotes here. Imagine you had the opportunity to stare into the oblivion that is the source code for Microsoft Office. What do you imagine you would see after you stifled the continuous and prolific amounts of upchuck, the vomit in your mouth? After you quelled the need to open source the content of your lunch on the floor, what do you imagine you would see in that code? What do you imagine you would see staring back at you from the void? What do you imagine you would see if you were to look at that source code and then compare it to something of analogous form and function in the open source world? And again, I have never seen the source code for Microsoft Office. I'm still alive. What do I know? This is a hypothetical here, friends. But imagine you had that opportunity and you compared it to something in the open source world, something like, again, hypothetically, OpenOffice. What you would understand is that the software that's developed by people working in open source tends to necessarily be far more modular. Well, why is that? Think about how open source software is developed. It's developed by people working in different time zones, speaking different human languages, sat in different offices, contributing at different cadences. Some people in the morning before they send the kids off to school. Some people in the evenings after work, once they're done with dinner, or before they've, after they've put the kids to bed. Some people on the weekends. Some people not at all for weeks at a time, and then they come back and they burst, and then they contribute, and then they have to go back to whatever else they were doing. Right? The contribution cadence for open source tends to be very erratic. The cost of synchronization, of communication for people working in open source tends to be very prohibitive. It's expensive to get everybody in the same room to have a discussion. If I want to make a change, I can't just turn my chair and say, Jane, I have an idea. What do you think of this? Can you help me with this? Let's work on that. Right? The cost of communication is expensive working in open source. It's not easy to get everybody in the same room. In fact, it's not even easy to get everybody in the same chat room. Because again, if I'm sat in California, and somebody else is sat in Southeast Asia, like China or something, my goodness, somebody's going to have to stay up late or go to bed early because it's not going to work otherwise. There's no way for us to be on the same bridge line, same call. So everything boils down into these long, slow, arduous email threads. Or nowadays, I suppose everything boils down to Slack threads that get lost because we never get to see them because Slack. So the cost of synchronization is prohibitive. It's slow. And as a result, it becomes very important to solidify, to formalize the component boundary of the code that you work on, of the piece of code that you care about. That way, other parts of the organization can depend on the stable surface area API of that component. As long as that's stable, then it doesn't matter what you do inside, in the implementation. This allows different parts of the organization to go faster, different teams to go faster. They can make changes to their component, and other parts of the organization can depend on that component. Now, this thing has to be independently deployable, right? You need to be able to deploy your component independent of other parts of the organization. Well, of course, I mentioned Microsoft Office, but it turns out that as you scale out the size of a code base, even if you are working in the same company, working on proprietary software, eventually you're going to have multiple teams. And the problem becomes manifest even there. Microsoft Office solved it by introducing COM, which is a non-answer, right? It's like the answer to the question nobody asked, which is how do I make it more painful for everybody, not just me, but for the entire world for 20 years. So eventually that requirement strikes everybody, right? Nowadays, though, independently deployable just means it's a separate process running in a separate server and a separate node, and I talked it over the network. It's not intra-process. It's not a intra-thread. It's not method. It's not intra-Java process invocation. It's actually another process running on another node. So we want small things that are independent. They're reusable by themselves. They work independent of the rest of the code base, and they can be deployed and updated independently of the rest of the code base. Small, singly focused, independently deployable, reusable, bounded contexts. Bounded context, of course, refers to Eric Evans' amazing book, Domain-Driven Design, in which he talks about the idea of a part of the domain that's self-sufficient. Identifying these bounded contexts is not easy. It's as much as an art as a science. The example that you often hear about is the context of sales versus customer service. Imagine you're building an application that supports sales, and you've got this idea of a customer. In this case, you have an entity that you're trying to sell your products to. You may have absolutely no rapport with that entity, with that person. You have no history, nothing you can take for granted. Compare that, for example, to somebody working in customer service. They're taking phone calls. They're trying to make better a perhaps unhappy customer. They're trying to remediate whatever situation that customer's in. They can take for granted a case history, a long rapport. They've sold them. They've got their whole information, etc. These are two different things. We may be tempted to treat them both as the customer entity in our massive ERD diagram, but they're not the same thing. And to treat them as the same thing muddies the concept of a customer support ticket over here and a lead over here. It makes them less crisp. And it requires that if I change that entity over here, I now have to communicate those changes and synchronize those changes to the people working on the code over here. Makes it harder for everybody. So identify these bounded contexts, tease them apart into small, singly focused, independently deployable, reusable services. Microservices. This is what we're talking about here. Microservices are an optimization on human agility. They give us, as humans, the ability to go faster, to deliver better software into production to the customer faster. And they have a lot of benefits, of which, of course, first and foremost, chief among them, is agility. There are some tertiary sort of technical benefits, though. It's easier to reason about the scope of a change if you have a microservice. You can understand that if I change this, it's not going to have a cascade that affects this entire thing. It's just going to affect this one little service. It's easier to use the right tool for the job. You can use different backing services for your service. You can use different languages if you wanted to, in theory. You can do all sorts of interesting things, and you have a lot of benefits, a lot of technical benefits as well. But let's be very clear. There's also some drawbacks to this architecture, some pain points. I call these the hemorrhoids of cloud computing. Do you know what a hemorrhoid is, friends? It's a real pain in the You're going to face two big hemorrhoids when you move to this architecture, two big pains that if you're ill-prepared for them, you're not going to appreciate. The first pain is how quickly can you stand up and deploy a single production-worthy service. Suppose somebody asked you to deploy Hello World. Just a string that says Hello World from a REST API. How quickly could you deploy that into a production environment, all of it? What would you have to do? How many things would you have to do to be able to deploy that? Most organizations with whom I've spoken, not yours, of course, not yours, surely not yours, but most organizations with which I've spoken have a dreaded wiki page. And again, I know it's not yours. Yours is better than this. But most organizations with which I've spoken have the dreaded wiki page, the wiki page with 500 easy steps to production. That wiki page is the enemy of velocity. It's the enemy of velocity. It's the list of non-functional requirements that we need to do before we can deliver line one of business differentiating functionality. And if that list is prohibitive, if it's exhaustive, if it takes forever to do, if it's cost prohibitive to do, then you won't do it. I'm not even judging you. It's just a natural sort of function of who we are. It's the human condition. If the system in which you find yourselves makes doing the wrong thing the easy thing, necessarily you'll do the wrong thing. So will I. There's a cost-benefit analysis that we all undertake before we undertake new work. What if I wanted to build a new service and deploy it into production, and it's going to support full text search? Well, the right thing to do there is to use something like Elasticsearch or Solr, right? But it's so much easier just to say, oh, well, it'll take a month to deploy it and get servers stood up and operationalized and secured and get people trained up and all that and get it integrated into the code base. So we don't have time. We have to get into production next week or 2 weeks, whatever. We can't do it. So we'll just try and shoehorn it into this full text search index in MySQL, because that's what Google does, right? For their search engine? Of course not. But you'll cut corners because you have to. Maybe you want to build a service that supports uploading and managing binary data, file uploads, that kind of stuff. The right thing to do there is to use something like Amazon S3, right? Or React CS. These tools are purpose-built for that kind of thing. It's scalable and it's efficient and safe. But again, the cost of setting all that up might be prohibitive. You might say, never mind, I'll just shoehorn it into an Oracle blob column. That's not going to blow up. It'll be fine. Nobody will care. Maybe you want to build a service that manages relationships. Relationships that are highly connected. Ironically, relational databases are terrible at this. Seriously, foreign keys in a relational database are a side effect of optimizations for sequential disk-based access from 30 years ago, plus. A foreign key is a pointer. It's an offset in a disk. It has very little to do with relationships. If you want to try it, try modeling a truly related, interconnected data set. Try modeling the Facebook friend graph in your MySQL database, and then doing a left outer join. Watch the whole thing fall over sideways. It's terrible at this. If you want to solve these, if you want to model this kind of data, use a graph database like Neo4j. But again, if it's cost prohibitive, you won't do it. You'll say, oh, I don't have time to learn this, to get developers trained up on it, scale it out, etc. If you want to build a service that, for random reasons, for no reason at all, just loses data all the time, the right thing to do there is to use MongoDB. But again, you won't do it. You'll just try and make do with dev null or something. It's just the wrong way. It's just the wrong way. So if getting past all of these things is cost prohibitive and you won't do it, you need to make sure that the situation in which you find yourself, the system in which you find yourself, makes doing the right thing the easy thing. You need to automate and codify all these different pain points so that the cost of delivering hello world into production is almost nil, virtually nil. It's the cost of writing a REST endpoint that supports hello world. That's the first pain. Then the second pain is, once you've done this, you now have invited, hopefully you are in a situation where even you have a proliferation of lots of small services in a production system. Lots of small services talking to each other, possibly over the network. That proliferation of services implies complexity, the complexity of building a distributed system. And if you're ill-prepared to address that complexity, you're not going to enjoy the journey. There's complexity in building distributed systems. There are patterns and primitives that we can talk about to support that complexity, and you should know about that. Now, these days, as often as not, to support that first use case, that first pain, we talk to organizations about Spring Boot, which makes the process of standing up a single production-worthy service as cheap and cost-effective as possible, as easy and pleasant as possible. And we talk about Cloud Foundry, which makes managing that service in a production environment, managing the life cycle of that service in a production environment, as cheap and cost-effective as possible. And then to address that second point these days, we talk to the organizations about Spring Cloud, which of course supports a lot of different primitives that supports a lot of different patterns that you can use for building distributed systems. And we talk to organizations about reactive programming. And this last one is really the theme, the thrust of our discussion tonight, of our journey tonight when we talk about cloud-native Java. We talk about reactive programming. Reactive programming is a recognition of the fact that our approach to building services has, for the last 20-odd plus years, served us well, but it doesn't serve us particularly well in the world where we have lots of data being conducted over the wire. We have lots of data being moved from one place to another in a service-based system. Think about the way that the world works in a monolithic application. You have human beings driving traffic to web pages. That's it. Everything else is done in the Java process. Data was moved about from database to Java process and back to the web client. But now you're in an API-based world. Data is being moved from one REST API to another, one buffer to another, one socket to another. Think about how Tomcat works. Tomcat is a web server. It's a web server that sits there. There's a server socket. The server socket accepts incoming requests. As a request comes in, the web server has a thread that gets spun up from a thread pool. And that thread is charged with producing a response and sending it back to the client. In that cycle, in that life cycle, it of course activates the servlet apparatus inside the web server, and then the servlet machinery then dispatches to the dispatcher servlet from Spring MVC, and then your controller code then produces a response that gets sent back to the client. All that happens in the blink of an eye, and it's so long as the time that it takes to take that request and then produce a response is faster than the time it takes for another request to arrive at the server socket, then everything's fine. Put it another way, if it takes less time to respond to a request than it does for another request to arrive, life is good. You'll always have enough threads to handle the requests. But if you start doing long-lived things, if you just start using that thread to produce a lot of data, as you will when you move to a world where everything is a REST API, then you start to fall into some trouble. You start to realize that it's inefficient. You've linked the production of that response, the I/O required to produce that response, to the number of threads you have in your web server. Threads are very expensive on the JVM. They're expensive on the operating system, and since the JVM and also the .NET CLR and other modern platforms ultimately use threads in the operating system, it becomes inefficient. You start running out of threads, and that means you are queuing incoming requests. And this link doesn't need to be there. This connection, this coupling from the production of a response from a given incoming thread doesn't need to be there. There's no reason that I/O needs to be associated with thread count. There have been ways to break this coupling for decades. In POSIX, anybody here know POSIX? Anybody here do C programming? All right, well, so POSIX is like the original standard, right? So in POSIX, we talk about the select function. You have the select function. You can give it a bunch of file descriptors, and it'll return when there's activity in one of the file descriptors. When I say file descriptors, I mean literally a pointer to something that produces data. That's a very old idea, old function. It's been around for decades. And the lowest levels of the operating system, on your operating system, when you do network programming, it's essentially fundamentally asynchronous. There's no way for you to sit there and wait for the next byte like you do with input stream and output stream. You get told when the next byte is there. And the operating system is able to handle that. You're able to say to the operating system, here's something that's doing I/O. Hold this for a minute, and you watch it. As soon as there's something happening, let me know. But in the meantime, I'm going to go do something else with my threads. This mechanism has been there forever. And so that would seem to be the cure, right? All we need is support for that in the JVM. Well, you probably aren't surprised to know that that's already in the JVM. It's been there since 1.4, which is also 15 plus years old. Java 1.4. Java NIO and channels. Is that enough? Are we done with that? Is that the solution we need? Well, no, of course not, right? That's not the solution because it's more or less equivalent to input stream and output stream. It's just the asynchronous non-blocking version of input stream and output stream. But I don't expect that you write your data access code using input stream and output stream. I don't expect that you're doing your web service responses using input stream and output streams. I don't expect you to do security using input streams and output streams. No, of course not. You think about things in terms of higher order types. You have this computational metaphor. You think about aggregates of your business logic, your business types, your foos and bars. And if you have a number of foos and bars, you return a collection of foo and bar, right? Well, a collection is a very convenient thing. It's a way to represent a multi-valued thing. But imagine for an instant that we had some alternative thing that let us talk about this world where we have this potentially unbounded amount of data that may or may not be available eventually. It may be available in 1 nanosecond, it may be available in an hour or a week. A collection doesn't really fit in that case, does it? A collection is finite. You have to be able to say, here it is, here's all of it. It has a size. So that doesn't really work for this sort of use case where we want to be able to say, here's something that's going to come here eventually, which is what we need. We need to be able to talk about things that are eventual, asynchronous. We need a computational metaphor that lends itself to this asynchronous I/O. So we need some sort of computational metaphor. Collections aren't going to work. And even if we had this metaphor, we do have this metaphor, right? We have the reactive stream specification. The reactive stream specification is sort of a convergence. It's an effort that represents the convergence from the reactor team at Pivotal, the Vertex team from Red Hat, started at VMware, the Akka team from Lightbend, TypeSafe, the RxJava team from Netflix. All these different teams got together and found common ground and extracted that into a specification called the reactive stream specification. It provides 4 very simple types. A publisher, which is a thing that produces records. It emits items. It's a thing you can think of as the equivalent to a collection. A publisher emits items, and the subscriber then consumes those items. When the subscriber subscribes to the publisher, it is given a subscription. A subscription is the session between the publisher and the subscriber. It's the link between the two. That subscription has a very interesting role to play. It is the thing by which the consumer signals to the publisher that it can only handle so many records at a time. It's how the subscriber throttles the production of data from the publisher. Those 3 types are mostly what you need to know. There's a 4th type called a processor. A processor acts as a source and a sink. It's a publisher and a subscriber. So you've got publisher, subscriber, subscription, which is the link between the two, and you've got processor, which is it's an interface that implements both publisher and subscriber. That's it. Those 4 types are all you need to know for the reactive stream specification. If you understand that, then you're already halfway there. Is that enough? Is the problem solved yet? Well, again, no, not really, right? First of all, think about publishers as being like arrays. An array, right? Arrays are useful. They're a way to represent a contiguous block of memory, and it's fine. But most of us don't write our code in terms of arrays, I would expect. I think most of us use collections for the ability to filter and transform and operate on data. These operators allow us to go more, to be more productive, to do things more efficiently, and we don't have to worry about resizing, things like that. There's conveniences that we can have above arrays. Well, is that enough? Well, still, we need something that supports that. So Reactor from Pivotal supports all these convenience operators. Still not enough, though. We have Reactor, we have the reactive stream specification. That isn't enough because nothing knows about it yet. Imagine if, for a moment, imagine for the last 15 years, what if Spring didn't understand a collection? What if the REST support in Spring from 2009 onward had no idea what to do when you give it a collection of T? What if it just threw an exception? It's like, I don't know, you want me to render what now? It could only do T. It couldn't do a collection of T. What if Hibernate had no idea about a collection? What if all these things just, for some reason, just ignored Java util collection types, lists, sets, whatever? They had no idea what to do with them. Well, you wouldn't use collection, would you? You'd go out of your way. You'd steer very clear of that type because you just know it would be a pain to use in these different frameworks. And the same is true for the reactive stream specification types. If nothing supports them, then what's the point, right? I don't want to just, life is not all about creating things that I can't render and store and persist. So there needs to be an integration for all these types. And this is where we begin our journey, is with Spring Framework 5 released last September. Spring Framework 5 is the first release of Spring to support these reactive specification types in Reactor. It ships a brand new web runtime called Spring Webflux. Spring Webflux is the reactive web runtime that we're going to use to build applications today. But it is only the baseline. It's only the beginning. It's not even to me, it's not even the sort of most interesting part. It's the thing that allows the rest of the Spring ecosystem to then embrace the reactive types. So Spring Data K was released, and that supports the reactive stream specification and Reactor, and it supports that with drivers that also support asynchronous I/O. We have Spring Security 5, which supports the reactive stream specification and so on. We have Spring Boot 2.0, which was released, a month ago, 2 months ago, very recently. Spring Boot 2.0 is the aggregate, the umbrella project that brings in all this stuff. And as we speak, the engineers behind Spring Cloud are working on Spring Cloud Finchley, which just released a release candidate 2 or 1 recently, like last few days, right? That's almost GA. All these different projects support, as the main theme, this reactive stream specification. So what we're going to talk about today, my friends, is building microservices, building cloud-native systems using Spring Cloud and Spring Boot and all these other projects, and doing so with a theme of reactive programming and building production-worthy systems. Now, I'm going to go ahead and build this here at my second favorite place on the internet. Start.spring.io. How many of you know this place? Oh, good. It's my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't already gone, you can begin a journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application today. I'm going to build a new service called the reservation-service, like so. I'm going to go ahead and choose a language. Can I do this in Kotlin? Will that offend people? No? Maybe? Who vehemently doesn't want me to do it in Kotlin? That guy. 2 people. Okay. What if I said it's close enough to Java? You could kind of squint and it's like. If you have questions, I'll translate. Promise. It's easy. Even I can do it. So we'll do it in Kotlin. And then we're going to go ahead and build an application today. We're going to build an application that uses Spring's reactive web support. Naturally, we need that. We want the config client support. There's that. Great. We want the Eureka service registration discovery support. Good. We want actuator for observability. We want the Kafka, Kafka streams support and Kafka support. So we want Kafka, and we want Spring Cloud Stream. So we're going to have Spring Cloud Stream Kafka for our messaging. We want what else do we want? We need some sort of persistence technology, don't we? We need some way to save data to the database. And here, I could click on this button, switch to the full version, and thereupon I'll be given a veritable ocean of checkboxes, and I'll see a number of different options here. You might be tempted to click on the SQL column, but there are none of these checkboxes that are prefixed with reactive. None of these support natively reactive. And that's because fundamentally they all boil down to the JDBC specification. And the JDBC specification doesn't yet support reactive programming. It doesn't lend itself to what we're trying to do here. It's fundamentally a blocking API. I'm heartened, I'm encouraged by some of the work I've seen coming out of Oracle. In 2016 at Java 1, they spent 2-3 minutes talking about reactive JDBC on a stage. And then 2017, a year later, that's 12 months in human time, they released a project, a very early project that sort of looked like a reactive JDBC. But it doesn't support the reactive streams types, which, by the way, are in JDK 9. So you know those reactive streams types I was telling you about before? They've since been copied, literally one for one, into Java util concurrent flow in Java 9. So it's not quite there yet, but I'm heartened, I'm Oracle. I'll get it done in my lifetime. So there's that. So we're gonna move on. We're gonna support something else. We're gonna look at something else that supports native reactive interactions. Okay. And here we have these NoSQL options, and these NoSQL options, there's a lot of different NoSQL options, and a subset of them support reactive programming. That's because we want to give you something that is natively reactive, fundamentally reactive, down to the driver and then back again. And so there's some twins here. You've got Redis and reactive Redis. You've got MongoDB and reactive MongoDB and so on. So our discussion has to be on which reactive technology we want to use here. Now, I could use reactive Couchbase. That's a fine choice. If I had Couchbase on my local machine installed, I'd probably use that. That's a nice choice. Reactive Cassandra, also a very nice choice. I don't happen to have that locally on my local machine, but again, fine choice if you want to use that. We'll look at reactive Redis later on. We will actually come back to that, and it doesn't lend itself to the domain that we're going to try and model right now, but it's a nice choice. We'll actually look at that later. So I guess that leaves us with reactive MongoDB, because when you want to lose your data, and you want to lose it reactively, there is nothing better than reactive MongoDB. So we'll go ahead and add that. Now, I think I'm happy with the selections made here now, so I'm going to go ahead and hit generate, and that'll give us a new project. And we're going to open this project up in our IDE. CD, downloads, UAO, reservation service. I'm going to open this up in IntelliJ. How many of you are using IntelliJ? I'm just curious. Cool, very good, very nice. What about Eclipse? Also very awesome. Good stuff as well, rock on. What about NetBeans? NetBeans, awesome as well. Love NetBeans, good stuff. What about Emacs? Are you here, sir? Emacs guy, where are you? Where's the one? Oh. It doesn't seem to matter which city, country, or continent I go to. Every single time I ask who uses Emacs, and he says, I do. And then he leaves. Presumably to troll again at the next place. It's the same human being. It's the same human. The same guy. One human being. Every country. It's ridiculous. So we're going to comment this out. We're going to comment out some of the bits that I don't need just yet. So for example, the config server, we'll get rid of that. The Eureka client, we'll get rid of that bit there. Kafka for now, we don't need this just yet. Okay, goodbye. And we're left with the bits that are required to use Kotlin, and we're left with the bits that are required to use Spring Boot. And I'm happy with those selections, so let's go ahead and build a new application. Now we're going to build an application that stores data into a database. So we're going to have a class that stores data, and we're going to map that data to an object that will then persist to our database. So I can create a Java-like class here I can say class reservation. I can give it a val ID string question mark equals null. So this is a field that's got an immutable value. It's not var, it's val, immutable. And it's string, but it's also nullable. So that's what the question mark is. The nullable means that I can null it out, or it could be null. And we're going to also have another one here, another field called reservation name, string, question mark, equals null. And I want this to be a ID, so I'll say at ID like this. And I'll make this a document that's going to be persisted into MongoDB. And so that's the that's a Java-like way of expressing this. But of course, this can be way better, way more efficiently done. I can actually, from here, I need to create getters and setters and equals and toString and all that stuff. So instead of leaving it like this, I'm going to do so more elegantly using Kotlin's constructors here, right? I'm going to use a Kotlin data class, okay? And the result of that is now I have one-liner that will, well, sorry, two-liner. That will persist, this will be mapped to a document in MongoDB. And what I want to do is I want to persist that object, that record, into MongoDB. So I'm going to create a repository. And again, here I'm going to be using the reactive Mongo repository support. The reactive Mongo repository support allows me to work with entities of type reservation whose key is of type string. And I could leave it as is, right? That's actually enough. Can you see that in the back, by the way? Is that font too small in the back?
Too small.
Too small? OK. Just occurred to me. Too small?
I think that should work.
Is it 28? Yeah? OK. I'm here for you, so if you can't see, you tell me, OK? It's OK, good. Alrighty, so there we go. So I've got this repository, and this repository is going to support the normal CRUD style lifecycle of data access, right? I'm going to be able to read, write, update, and delete data from MongoDB given this type. Now I'm very happy with that selection. I'm very happy with that choice there. I could, of course, create custom finder methods. I could say that this interface provides a method like flux of reservation, fun by reservation name, find by reservation name, and that will return a flux of reservation, like so. There we are. So that's my custom custom finder method there. And that will actually return that will actually generate a BSON query that will be interpreted for me or evaluated for me by the Spring Data runtime, and it'll result in a BSON query that selects all reservations using the reservation name and having a predicate rn. So the predicate will be matching rn, which is the thing I'm passing in there. So I could do that as well, but I don't need that in this case. I'm happy with the selections I've made. And this repository will support all the normal kind of things you expect from Spring Data. So you've got creation, reading, updating, deleting. But here you can see that these methods, they support a slightly different variant from what you might be expecting if you've not seen yet the reactive support here. These repositories accept publishers, the same publishers that I talked about earlier, the reactive streams publishers. The publisher has a subscriber. The subscriber takes the subscription, and the subscription can be used to say, I want 10 more records of, whatever, or 1,000 or whatever you can handle. Each time there's a new item that's been emitted, the onNext method gets called, and each time there's an error, the onError method gets called, and when the publisher is done with its emissions, you'll get onComplete. So this is the reactive stream specification there, and you can see it accepts this reactive type, a publisher. It returns a mono or a flux. These two types are specializations of the reactive streams publisher type that are in Reactor. A mono is a publisher that produces 0 or 1 record. Think of it kind of like an asynchronous and awesome future, JavaUtil completable future, right? We also have a flux, which is a specialization of the publisher type, and a flux is a publisher that produces 0 to n records, 0 to potentially unbounded numbers of data. What's the distinction? Why should you have two different things that both extend publisher if they have the same contract ultimately? Well, think about if you're given a publisher and you're asked to render a screen, a user interface. Should you show a detail page for the details of one record, or should you show an overview page with a scrolling table? How do you know? If you're given a mono, you probably want to display the details. If you're given a flux, you should probably render the table, as an example. The semantics are useful, that's all. There's some operators that make sense in those cases, but these are also sort of analogous to equivalent things in ArcsJava, for example. So there's a lot of precedent for this kind of thing. Now, we have this repository, and we're going to use this to write data to the database. Now, I'm going to create a bean of type initializer. I'm going to create an application runner. It's going to be called the initializer, and initializer, and it's going to implement the application runner interface, and it's going to be a Spring bean that's going to override the interface, and it's going to be, like I said, it's going to be a Spring bean, so I'll annotate it there. And I'm going to tell Spring to inject a pointer to the reservation repository here, and we'll then write data to the database here. So I'm going to say val names equals flux.just, and we'll use some names. My name is Josh. It's so nice to meet you. Christoph, how you doing, buddy? Jürgen was here a minute ago. He gets to play. And I need some other names. What about you, buddy? What's your name? Nick, N-I-C-K?
Yeah.
Very cool. Nice to meet you. Miss, what's your name?
Iris.
How do you spell that?
I-R-I-S.
Very good. Nice to meet you, buddy. Thank you. What about you, buddy?
Peter.
P-E-T-E-R?
Yeah.
Very cool. Nice to meet you, buddy. Thank you. Miss, what's your name? Yeah?
Ricarda.
How do you spell that, my friend?
R-I-C-A-R-D.
Like that?
N-A-A.
Like that? Okay, very cool. Nice to meet you, buddy. Thank you so much for that. One more victim. I'm sorry, volunteer. Who wants to be my next volunteer? What about you in the glasses back there, sir? Green shirt? Yep, hi. How do you spell that? Y-U? H-S? U-A-N. Like so? Very cool. Nice to meet you. So that's 8 names. It's a nice round number. It's 8. So it's divided by 2 and then 2 again. It's still 2. It's a nice number, right? And I'm going to go ahead and visit each one of those. What I actually have here, by the way, is a publisher. Remember, like I said, it's a publisher of string. So I'm going to treat it as a flux. This is type inferred language, like Java 10. And I'm going to visit each one. I'm going to say names.map. And when I use the map callback, in Java, you would say map, and then you have a callback here, and you say name, and then you take each name and turn it into a reservation. So I'm going to say null for the ID, and then I'm going to pass a name. And that's certainly fine. That incantation works just fine. But it's a little Java-ish, isn't it? It's a little bit more code than we need to write. So let's break it down. First of all, if you in Kotlin have a parameter that's expressed as a lambda, and it's the last parameter or it's the only parameter, that parameter can be written outside of the curly brackets, the parentheses. In fact, you don't even need the parentheses if it's the only parameter, right? So I can take away that. Also, I have this lambda, and it has 1 argument. Well, it turns out that having, in a functional language, lambdas that take just 1 argument are a super common thing. And so they've made it simple enough to just omit this. There's an implicit parameter called it. It is the string in this case. So I can replace this with it. Also, in Kotlin, those fields that I created here, this got turned into getters and setters and also a backing field. Well, those fields are also named constructor arguments. So I can say reservation name. So there we go. The Kotlin way of doing that, right? Now, I'm going to go ahead and map each one of those reservations. I'm going to say map again and turn that into a reservation record that's been saved here. So I'm going to save it to the database. Now, the result of this is a publisher. I'm going to get a mono back. So save returns a mono. So really, if I look at this, it's actually a publisher of reservation, right? So there we are. Now that's not what I want. I want to unpack the intermediate type. I don't want that intermediate publisher, so I'm going to use flat map. And flat map is going to give me the correct arrangement here, right? And actually it's a flux, but you can see what's happening. Now, what do you think is going to happen at this point if I run this code? Nothing. Yeah. This code, quite like me, is lazy. You have to force it. You have to coerce it into doing work. And the way you do that is by subscribing. You say save.subscribe, and then you visit the records and print it out, for example. That's an option. This code is OK. It's fine. I can save it and subscribe and so on. But we have another problem, a lurking problem with this code. How many of you know the expression in English that a broken clock strikes true twice a day? It means, by virtue of the fact that the hands on the clock are fixed when it's imagine the clock is broken, so the hands aren't moving. The hands are fixed in place. That means that on every day, for at least 2 instants in that day, in the morning and in the afternoon or evening, that clock is correct, right? Even though it's broken, it's correct at least twice a day because it's always going to be 7:30 in the morning and it's going to be 7:30 in the evening, for example. And the same is true for MongoDB. MongoDB will sometimes write your data to the database. Not always, not even most of the time, but sometimes. And so I want to avoid duplicate data here. I want to make sure that I've deleted everything in Mongo so I don't have any extra duplicates, one or two out of the millions of records. So I'm going to go ahead and do a very simple reservation repository that delete all. I can do delete all, and then that's going to give me another mono, another publisher. So I could, I need to subscribe. I could do subscribe, right? It's fine. But what happens with this code? What's wrong with that? That code is asynchronous. The code is going to run asynchronously, so there's no guarantee that this line will finish before this line here, these 3 lines down here. So I want to force this line to run. First, I could say .block, for example. And in so doing, I'll be forcing it to run. But this is a terrible way to solve this problem. We have this nice reactive API, and here we are blocking. Don't do that. That's a terrible idea. Instead, use the operators. Use the Reactor API to say that you want to delete everything, and then you want to do the following. And you can do that like this. Pass in all the intermediate data there. Take that whole thing, pass it into the then many. And then I'll say reservation repository at find all. And then I'm going to finally subscribe to the data. Print line it. Okay. So I'm using this nice reactive API, and I'm saying do this first, then do this, then do that, then subscribe. I'm using this reactive API to build things that are fundamentally asynchronous. Remember, there's no guarantee that this line will happen on the same thread as this line here, or this one. There's a scheduler behind the scenes, and you can control that scheduler. You can say schedule, subscribe on rather. Subscribe on schedulers dot from executor, and you can provide a Java util concurrent executor. I can do that, but I need to use these operators. There's no countdown latches. There's no cyclic barriers. There's no phasers involved here. There's no semaphores. This is just asynchronous code that works. It's deterministic. I use the API the right way, and I get the right results. I don't have to worry about all that. Now, the other thing is this is a little tedious. I've got this whole top-level type here, and all I care about is this little block of code here. So it's a little tedious. So we can simplify that by maybe using Java configuration. I can say @bean fun runner, for example, and return a application runner in the application runner definition there. And I'll just copy and paste all that. OK, and paste that here. All right, I'm going to inject the reservation repository. So I'll say reservation repository is equal to reservation repository. That's a little bit nicer. At least that way I don't have a top-level type polluting my namespace. I've got a side effect that I care about, and it's just sort of a method on a class. So that's a little bit nicer. But in Kotlin, we have this, even in Java too, but it's really nice in Kotlin. You have this nice DSL, functional or programmatic bean definitions, right? So here I can say add an initializer, and I can pass in this nice DSL here. And beans lets me programmatically register beans, like so. And so I can take this whole thing, and I'm going to tell the programmatic bean definition DSL to give me a reservation repository. I'll say look up the definition using this ref method here. And the benefit of that is that I can get rid of this. And by the way, keep in mind, this is a top-level class, and this is a top-level function, right? So now, you have to keep in mind, this DSL this is actually a method invocation here. I'm defining a bean inside of a block, basically. That means that I can do interesting things. I can say, oh, if math.random is greater than 0.5, then define this bean, right? Or I can do a for loop or something, or whatever. Like this is stuff that you could have done before, a little bit, using bean factory post processors and stuff like that, but it wouldn't have been as well. It made me want to take a shower. It wasn't really great before. So this is nice. You have this nice programmatic way of registering beans, and that's fine. And it's something you can do in Java. You can definitely do it in Java as well. But the initializer syntax here It's expecting an application context initializer, which is a, the API is, it's nicer in Kotlin, okay? So there's that. So let's go ahead and run this application. We've got our data access layer. We've got some data in the database. Let's go ahead and run the application. Let's see what we get. First time, go. I'll drink some of this tea. I drank all the tea. All right, look at that. It worked. Of course it worked. It was a demo. What were you expecting? That was always going to work. Instead, what I really wanted to talk to you about was this. This is the ASCII artwork in Spring Boot. This ASCII artwork took a long time to get right. You see, we on the Spring team have many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics, star stuff, the very celestial bodies in the heavens above us were their daily bread and butter. So it makes me very happy to imagine that someday, somewhere, somehow, there was a GitHub issue that says, damn it, we need good ASCII artwork. And I think you'll agree they did a great job. So it's for this reason, and this reason alone, that I want to take a brief digression, an ever so brief digression, to talk about what I consider to be a very serious and glaring deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be particularly short-sighted. Do you see this checkbox? It says hide banner. What the hell? Why is that even there? That's a dumb feature. So I did what all of us would have done in that same situation. I'm not a hero. You don't have to thank me. I went on the internet and I complained loudly. And I sent a message of hope from my friend Jan Sabron. Does Twitter not work for me? Okay, here we go. My friend Jan Sabron sent me this message of hope, which I share with you today. Jan Sabron is a... Too large for life. There it is. Got it. Go away. Jan Sabron is a software developer by passion at IntelliJ JetBrains. And he sent me this message of hope, which I share with you here now today. 1 second. Loading. Still loading. Still doing it. Loading. Come on. There. Don't worry, my friends. Hope springs eternal. So, I'm waiting for that patch. I mean, that was like 2016, so he keeps saying it's going to be in the next build. But I'm still waiting. In the meantime, some people ask me, can you change the ASCII artwork? Can you change it and do your own? And that's a ridiculous question. Know your limitations, know your role. You're not going to be able to do a better job. What do you think? But maybe you could. Maybe you could. So if you feel like you're that good, I'll show you how. CD downloads reservation service. Copy. I'm going to copy from the desktop here my banner.txt file to source main resources banner.txt. And then I'll go to the application here. Maven clean spring-boot :run. Hit enter. Take some tea. Not bad. Not bad. Now there's a few things to appreciate about this ASCII artwork. It says meow. I think so. I think we should. And then of course there's this guy right here who's I love this guy so much. So awesome. So that's pretty good, right? Not bad. But arguably the best feature of Spring Boot 2, which is actually what we're going to talk about here today after all, the best feature from Spring Boot 2 is this. So beautiful. The best thing we've ever done in Spring in like 15 years. Oh. Yeah, sure. I don't even care if it adds like 30 seconds to the startup time. It doesn't even matter. Totally worth it. So worth it. Oh, it's so beautiful. Oh, I'm so happy. Okay, anyway. It is not lost on me, unfortunately, that of all the things to not be asynchronous and reactive, that is the one. So I'm gonna go ahead and remove it for now because I don't want to spend 30 seconds in our demo for now. Okay? All right, so we have data being written to the database. It's fine. And we have Bootiful ASCII artwork. Now, we've got data in the database. Are we done? Of course not, right? We're now confronted with an existential question, something with which I'm sure we all wrestled at university, which is if we write data to the database, but we have no REST API by which to access it, did we actually write the data to the database? And the answer, of course, is no. So you could have skipped that stupid philosophy class. We need to build a REST API, and there's a number of ways we could do this. We could just use a REST controller, Spring MVC style REST controller here, like this. Reservation REST controller. And create an endpoint, get mapping, /reservations, fun reservations. And I'm going to inject the reservation repository here, like so. And I'll say this .reservation repository.find all. And voila. Okay? Reservations. And I'm going to run this application. And that works. That'll work. That's a, it should look fairly familiar if you've ever used Spring MVC. It's a REST controller. It's got a bean that I've injected through the constructor there. It's got a get mapping endpoint. And if I go to the browser, which I should start up here, localhost 8080 /reservations. There you are. There's the data. That worked just fine, right? Now, this is Spring MVC style, but let's be very clear. This is not Spring MVC. It looks very familiar, and this is indeed the same annotation as you would use in Spring MVC, but this is not Spring MVC. Remember, the return type of find all is a publisher. Thus, the return type of this method is a publisher. It's being type inferred in this case, but it's a publisher. So think about what would happen in Spring MVC if you had Spring MVC right now. Something in the framework has to take the return value of that method, accumulate it, and wait for the, get the whole response, and then pass it to something like Jackson or DOM, and turn it into JSON or XML. Well, that's a publisher. We don't know when that's going to complete or if it'll ever complete. It might finish in one record. It might finish in a trillion record. It might finish, as long as there's heat in the universe, it'll keep producing new records. We don't know. So we can't sit there and accumulate records in memory and then pass them to DOM when we're done, or to Jackson. So we have to stream through the data and encode each record as we can, which we do, right? We actually ended up having to work with the Jackson team to be able to support this. There's a lot of magic that has to happen to make this work. This is not Spring MVC, and this is not Tomcat. I'm running on Netty, not Jetty, Netty, the reactive library. This is a completely different web runtime. It's called Spring Web Flux. It's net new. It's based in Spring Framework 5. So we have this style, and I like the style, and this is certainly very popular and very familiar if anybody's ever used Spring MVC. But there is a different approach that you can take advantage of in Spring Framework 5 called functional reactive endpoints. So what I'm going to do is I'm going to create another bean here and use another nice DSL called a router. And here, I'll use these functional reactive endpoints. Whoops. So I'll say that I want to return, first of all, I'm going to inject the reservation repository there. I'll say ref reservation repository. Server response.ok.body reservation repository.find all. Now, if I commented, I've already commented that one out. Let's go ahead and restart. And reservations. So same thing, just much more concisely written. What's the difference? Well, one is a predicate paired with a function, and the predicate is an object. This DSL that I'm using here results in a request predicate. That's an object that you can provide as well. You don't have to use our DSL. You can use your own request predicate. You could have a request predicate that says, oh, well, if Mercury is in retrograde, then match this request. You know, if NASDAQ is above a certain threshold, whatever. Arbitrary things there. Whereas before, with Spring MVC, these mapping annotations are very, very flexible, but they are ultimately, at the end of the day, just data. There's no verbs associated with it. Annotations are only useful if Spring understands how to work with them, right? If you cannot express how you want to match requests based on these annotations, then you have to do an end run around the annotation and go one level lower into Spring MVC itself, into the handler mappings. So that's one thing that's kind of different. The other is that these are more direct. There's not actually any reflection happening here. Right? There's no component model here. Basically, we've got a direct pairing of predicates to handlers, to handler functions, and you can actually use method references if you want to. For example, you can actually just say, here's a request mapping, and then here's the thing to call. I'm actually hard coding a lambda right directly in line. But the benefit is that you can actually have classes that have these functions, even in Java, and then have all of the mapping information in one place. Whereas with Spring MVC, the mapping is on the controller method that handles the response. And those may be in different classes, in different packages, in different places. There's no single view of all the endpoints in the application, whereas you could have that with this. So when do you use which? Well, it's up to you. Like, there's a lot of frameworks in the Java ecosystem that support this idea of a class and a handler method that supports the production of a response, right? So if you've ever used struts, there's this idea. You've got JSF, you've got Spring MVC, you've got WebWork for a while. I mean, a lot of different things have this basic structure of a class and a callback. Whereas there's also a growing ecosystem of things that support this idea of a predicate and a handler method. If you've ever used Sinatra in the Ruby world, or if you've ever used Scalatra in the Scala world, or Ratpack in the Groovy world, or Spark Java in the Java world, or Express.js in the Node.js world, they all work in this style. So when do you choose which? Well, it's up to you. Like I said, you can also mix and match. One is not right or wrong. They're just different. And if we take a moment and get rid of that code and get rid of this code here, the code associated with the application runner, you can see that what is left is trivial. That's my whole application, right? I got rid of the application runner because obviously in a production application, you're not going to write hard-coded data to the database, right? This is just for our demo. So that's the whole thing. It's the REST endpoint with reactive data access. Pretty concise. I like it. It's simple. It's a simple example, but it does demonstrate, how nice and svelte things can get these days. Now, undo. No, what is it? Come on. What does that even mean? Huh. That's weird. All right. So we've got data. We've got a REST endpoint. Are we done? Let me run this application. Not that one. Goodbye. Goodbye. All right. So we've got data. We've got data in the database. We've got the possibility of beautiful ASCII artwork. We've got data access, reactive data access. Are we done? Can we go to production yet? I'd say no, of course not. There are things that we need to concern ourselves with that, left unaddressed, will cause our movement to production to be rather spectacularly painful. One of these things that we need to support is this idea of observability. Observability is this insight that when things go wrong, we need to be able to surface as much information in the application as possible to support the remediation of that application. We can do this in part with the actuator. The actuator is a set of endpoints that Spring Boot provides that allows you to see what the application is doing, to see its state. And in order for us to use that, I need to actually, first of all, I need to say I want to expose all the actuator endpoints in this property file. I'm going to say management endpoint web exposure include equals asterisks. And then I want to show all the health details as well from those endpoints. And with that in place, I'm just going to go ahead and restart. Or set my brightness. That's another thing I could do. Okay, Kotlin. This is the only thing I have to wrestle with. There's a Spring Boot launcher and there's a Kotlin launcher, and they are not the same thing. You have to remember to set single instance only. Otherwise, IntelliJ makes your life miserable. Okay. So, refresh, 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 refresh. Great. Now go to Actuator, and you get these endpoints. Or don't. Okay. There you go. So you get these endpoints that are different endpoints that you can look at to see what the application is doing. To see all the different auto-configured beans in a Spring Boot application, you go to the beans endpoint. To see the health of different subsystems in your application that may fail, like your MongoDB connection factory and your disk space, your data source. All this kind of stuff is going to be shown here. If you have something that Spring Boot is not aware of, you can configure a health indicator for that as well. All the different Spring Boot auto configuration conditions that were evaluated and that are evaluated into true or false or whatever, all those are listed here as well. The different configuration properties that you could, for example, specify in application.properties are listed here. These are the properties that apply to the current types on the application context. We have the environment endpoint, which shows me the different system properties, environment variables, and all the property sources of which Spring Boot is aware. The info endpoint, which is blank by default, but it's up to you to put identifying information, things like the service ID, the git commit ID, the build date, things that you can use to understand what version of the software is running in production. The loggers endpoint shows you all the different logs and their log levels, and you can also post to this endpoint to change those log levels. You've got the heap dump and the thread dump, which both give you, just that, dumps of the heap and the thread count, so stack trace. You can throw that into a profiler for the heap dump. You've got the metrics endpoint, and the metrics endpoint shows you keys and values that describe interesting things about your application, the number of HTTP requests, the CPU size, all that kind of stuff. Now, these numbers are things that you could probably easily glean just by looking at the platform. So Cloud Foundry, for example, will give you some of these numbers. But the intention isn't that you just leave these numbers as they are. It's that you also collect your own custom numbers. And so you can, first of all, look at the details of one of these numbers. Maybe we can look at HTTP requests, HTTP server requests. So grab this. Okay, and we go to metrics / HTTP server requests. And when I do that, I'm shown statistics about that metrics, the count of requests, the total time, the maximum time, etc. I can see also tags. And these tags are dimensions of data by which we can drill down into this statistic, this metric. So we can see, for example, that there's this metric, but we can also ask it how many metrics, how many requests do we have where we had an exception of type response status exception. We can also ask it how many metrics do we have, or how many requests do we have where we have a HTTP method equals to get, etc. These extra dimensions give us the ability to ask really interesting questions. And you can store this metric information in memory like we are doing here, but it's much more useful if you use the full micrometer API. Micrometer is this API that we're using in Spring Boot 2.0. It's what underpins the metrics endpoint in the actuator. Micrometer is an application metrics facade. It publishes metrics to monitoring tools, to time series databases, to things like that to process. A time series database is another database that is in Oracle. It supports managing keys and values over time. It's like Redis, but there's a whole dimension of time, right? And the really valuable thing about these is that they support interactions with graphing tools, visualization tools. And this micrometer is an API that you can use with a number of different monitoring tools, including Prometheus, Netflix's Atlas, CloudWatch, Datadog, Graphite, Ganglia, JMX, the Tick stack, New Relic, StatsD, SignalFX, and Wavefront, among others. All these different tools are useful, and they support, as I say, visualization. There are a number of them that support, for example, Grafana. Grafana is there to visualize information. Remember, your brains are optimized for pattern recognition. Is there a tiger hiding behind the tree? That's what our brain is good at. not sterile JSON stanzas in a REST endpoint somewhere. If you want to see patterns, if you want to understand the data, visualize it. These tools support that. You can use that to derive insight into drive change. Now, are we done? Can we go to production yet? I'd still say no. There's things that we need to care about. I've built this application, and we've configured parts of it using application.properties, and all these different properties are in the property file. But what if I want to centralize that configuration? How do I support that? What if I want to reload the configuration? How do I support that? What if I want to version control and audit my configuration? How do I support that? And what if I have sensitive information, passwords, locators, credentials, stuff like that I don't want laying around on my file system at rest unencrypted? How do I support that? For all these use cases and more, while what I've got is a good start, it's not nearly enough. Instead, I want to use I want to store this configuration somewhere central. So I'm going to use some sort of server to serve up that information. I could use a version control system. There's a lot of good version control systems out there. There's Git. That's a very popular choice among the startup scene. In the enterprise, I've seen a lot of people using Git. That's another great choice. I feel like the hipsters today, the real dedicated hipsters straight out of college, they're also using Git. I mean, it seems like there's a lot of good choices here. Git, or Git, or Git. All of them great choices, and you should feel free to choose one of them. Now, we can use these to support our versioning and our auditing requirement. I can see who changed what and when, and if necessary, to roll that change back. That's a good thing. It's also centralized. So that's nice. Well, centralized in that there's one source of truth, and that there could be one source of truth, as opposed to having to tediously copying and paste values from one server, one config server to another. So that's certainly a good start. But what about the live reconfiguration? What about the security? You know, the encryption, right? So for these, we need something a little bit more sophisticated. So we're going to use a config server. We're going to build our own little config server based on the Spring Cloud config server. So config, whoa, there you are. Okay, and the config server is going to manage access. Come on, Wi-Fi. The config server is going to manage access to a directory full of configuration. Whoa, what just happened? rmrf config service. Whew. That was scary. UAO. Nope. I don't know what's happening, but I don't like it. It's giving me demo. Okay, config service, rmrf demo. Config service, config server, generate. Config service. Whew. You all saw that too, right? That was weird. All right, so my config server is going to manage, it's going to mediate access to a directory full of configuration. That directory of configuration is going to live here. It's on GitHub. I'm going to go ahead and clone it, assuming the Wi-Fi indulges me. All righty. Git clone to the config directory on my desktop here. All right. And this config server is going to need information in of itself to do its work. So we're going to say that the app's going to run in port 8888. It's going to run and manage this directory full of configuration. Spring Cloud config server get URI equals home desktop config. And then the config server, in order to do its work, it needs a little bit of information. By the way, look at that Java code. There. It's almost all the Java code I'm going to write tonight. Not quite. There's like 5 or 6 more annotations. All right, so that config server is going to be available now. Localhost 88 reservation service default. So you see, when I go here to reservation service / default, I have information. That information comes from the property files in this config directory, just a bunch of property files. I have a property file here called reservation service.properties. That property file has keys and values, like for example, message equals hello Sydney. Well, this is nonsense. This message makes no sense at all. I haven't been in Sydney in like a month. And did you know on Saturday I'm going to Melbourne? So that's awkward. It's just awkward. It's just wrong. You know how upset they're going to be when I go to Australia and I'm not even I don't even have the right city for the message? About as upset as you are. They don't have the right city for Austria. So we need to fix that, clearly. So we're going to go back to my reservation service here. I'm going to go back to the build. We'll change this to bring back the Spring Cloud starter config client here. And leave that out, okay. So we've got the Spring Cloud starter config dependency on, in the client. And I want my reservation service to now start up and take advantage of the configuration in that config server. And you can see the configuration here. It's two different property sources, one from reservation service.properties and the other one from application.properties. All microservices, no matter what their name, will see the configuration in application.properties. But only the microservice called reservation-service will see the configuration in reservation-service.properties. So let's take advantage of that. We're going to see that the application will start up on port 8000 and it'll have access to this message, hello Sydney. So say spring.application name equals reservation-service. And of course, for the Spring Cloud config client to do its work, it needs to know where to find the config server. So I'm going to say localhost 8888. Now, this is the default value, actually. So if I comment that out, it's still going to work. I only show it to you because I care. I'm a giver. But I might forget for the rest of our time tonight, and I just want you to keep that in your noodle. Keep that in the back of your noodle for later, okay? So if you change the host, you need to specify that value. I'm just using the defaults. Of course, it works on my machine. So I'm going to go ahead and start the application up. And before we do that, let's go create a new REST endpoint. At get /message. And I'm going to inject the message here. Server response.ok.body. I'm going to inject the message from the environment. So environment will be ref environment. Whoa, whoa. No. No. Definitely not that one. You have gone the wrong way, sir. So a couple things I should also mention. Notice that I used ref here. Ref is a Kotlin method, and I'm using it to look up beans of type reservation repository, but I didn't have to specify a class literal. You didn't see me specify reservation repository that class. That's because Kotlin supports this sort of pseudo reified generics, right? Basically, this method doesn't exist. It's a macro. When Kotlin compiles this method here, it copies and pastes the code from this definition here into the call site. And because it's going to do that, it can do some nice things for us. We can specify inline and reified t. And when it does that, it basically stores a reference. It says val t equals reservation repository class, right? It does that in the code behind the scenes, and it rewrites the code behind the scenes so that whenever the method definition here, whenever this method ref is defined anywhere and it references t, it can actually refer to t.class in the code. And t, of course, is the generic type from the generic parameter. You can't do that in Java because, you know, Java. But we can do that in Kotlin, and we can get around some of these limitations. So we have this ability to do that. This is one thing that's nice. And similarly, here, in this method, in this findAll, this body method, normally in the Java version of this API, you have to specify a class literal here. Class, right? You have to specify a class literal there. Well, we have this reified, pseudo, quasi reified generic thing happening here. So I don't have to do that. So I'm going to now use the env thing. I'm going to say I'm going to create a publisher that has just one value. It's going to be the property that I'm going to get from the environment called message, right? And I'm going to take that val message. All right. So what's happening? Flux.just publisher of string, please. Somebody's got a phone call. So Am I doing something wrong? That worked. So val message prop equals, and this is a string. Oh, string class. That should be the default though. Oh, you know what it is? It's nullable. So you have to remember in Kotlin to tell it the right type. It's nullable here. I want to tell it to ignore that. I want to tell it to just go ahead and do it anyway. So the way you do that is you yell at it like this. You yell at your computer anyway. Now there's a formal language syntax for it. Right? You could also say, okay, I know it could be null, and if it is null, then give me this optional thing, and that's called the Elvis operator. So question mark, colon, you know, whatever. See, Elvis? If you look at it sideways. See, it's from Groovy as well, right? So that's what's happening here. I prefer to yell. So I'm going to take that, put that in there. That's fine. I'm going to take this, put that in here, and that's fine. And we're back to where we started. All right, now this is nice. I like env.getProperty, but in Kotlin you can do method overloading, so you can actually do this as well. And in that case, it's not needed. There you go. Oh, that's delicious. Okay, let's see. So localhost 8,000 message. Hello, Sydney. It's the old message. It's not correct. We need to change that, obviously. So let's do that. I'm going to go to the desktop config directory. I'm going to open up the property file here, reservation service.properties, Emacs, reservation service.properties. It's me. All right. So hello. How do you say hello? Is it just H-A-L-O? Like that, or what is it?
A-L-L.
Like that?
Perfect.
Okay, do you have the comma, or is it just, is this enough yelling?
Absolutely.
Okay. Git commit -a -m, YOLO, git status, good. Now, if I go to the config server localhost reservation server result, you can see that it is immediately aware of the updated configuration, obviously. But my microservice here, no idea. It has no idea what's just happened. We need to force the microservice to update its configuration. And the last thing I want to do is to restart the server. So instead, I'm going to tell the microservice, I'm going to tell it to refresh itself using a refresh actuator endpoint. So curl -d http localhost 8,000 /actuator /refresh. So I'm sending an empty HTTP post, and the content type is application JSON. Can you all see that in the back? Is that okay? Okay, and refresh. So I hit enter as fast as I could, and then went to my browser, hit refresh, and I can see the updated configuration immediately. Right? It reconfigured the property source, and it was able to refresh it. I can also be, you know, in this case, the property source is automatically updated, so nothing had to happen. But I can write code. For example, I could have an event listener at event listener that listens for a refresh scope refreshed event. Class, okay, fun on refresh, and it's a RE. And then in this callback, whenever somebody calls that actuator endpoint, I could do something to respond to the updated configuration. I could pull down the configuration value and then reconfigure my own state. Or, even better, if you have a bean at component, whoops, class, you know, foo, you could actually make this bean refresh scoped, in which case Spring will recreate the bean whenever that event gets called, whenever that event actuator endpoint gets called. So you have a lot of ways you can recreate or reconfigure your application state based on live reconfiguration. So we looked at how to centralize configuration in this case. The centralized configuration is nice because we have an intermediary. You can configure security for the intermediary from the client to the config server and from the config server to the config Git repository, right? You can configure encryption by using key-based authentication for both the config server and the config client. If they have if they do key-based encryption or authentication rather, then you can support symmetric encryption and decryption. You can have values in your property files that are encrypted, that are only decrypted in the client process, not over the wire, not on the server, only in the config client process, right? So that's nice. You can have it at rest encrypted. Or you can use Spring Cloud Vault, which is actually another alternative for this, and that works as well, right? Okay, this is centralized configuration. The next thing that we want to support in a dynamic cloud-based service environment is service registration and discovery. We want to be able to find and work with other services dynamically and quickly and capably. And we could use DNS, but DNS has some limitations that make it sort of a poor fit in some situations. First of all, DNS is a very simple protocol. It'll tell you where something lives, but that's not the same as knowing if it lives, right? You may know that I live in sunny San Francisco, and if you ever should be in the neighborhood, don't hesitate to reach out to me and say hi. I'm always happy to talk about all things Pivotal and Spring. But that said, knowing where I live doesn't necessarily tell you if I'm alive. I know it's a little morbid, but bear with me. I could be dead on the floor in the kitchen, right? Knowing that distinction is important. Knowing where I live is different from knowing if I'm alive. The same is true for your production systems. Knowing where a service's DNS points it to is not the same as knowing if that service is going to respond. Right? That coupling is unnecessary. There's no way to imply one from the other. The DNS address doesn't imply livelihood of a service. So if I make a call to a service that's not going to respond, I hopefully have done the right thing, just as you have all hopefully done the right thing. You've all read and internalized and applied Michael Nygaard's amazing book called Release It, of which the second edition was just released. And in so doing, of course, you've specified aggressive client-side timeouts. You've all done that, right? For all the HTTP code in all of your code and all of your libraries and all the libraries that your libraries have. Everywhere. All your operating systems, your platforms, your web servers, everything, you've done that. You've all done that, right? 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 Pop quiz, what's the default timeout for JavaNet URL connection? Don't everybody raise your hand at once now. 0, right? It's going to block in perpetuity. That's the worst kind of tuity. It's going to block forever. So unless you've remembered to specify that that's going to time out only after 30 seconds or something, it's going to block. If you've got 100 threads and you've got 101 requests and 100 of them are waiting for that response that's never going to come, you're in trouble. So hopefully you've done all that. But it's much better just to be able to ask the question, is that service there? If it's not there, then I'm not going to make the call in the first place. Right? So we can support that with a service registry. So there are a number of different service registries out there you can use, and Spring Cloud supports all of them through a uniform interface called the Discovery Client. I'm going to go ahead and build a service registry using Eureka here. So I'll call this the Eureka Service Registry. Config client, I'll get my configuration from the config server. CD downloads. Oh, Wi-Fi. UAO. Eureka service. And we open this up. Spring application name. Eureka-service. And Eureka service application. All right. Spin that up. And that's going to start up on port 8761. 8761. There you are. A couple things to appreciate about this. First of all, really, really, really well done mouse over. That took like a year. Not even kidding. It was the wrong logo for like 6 months. It was a different Spring project altogether. It took a year. Anyway, the other thing that we have to notice is that there are no applications registered here. right? No registered instances of the application. So we need to teach our reservation service to register itself and make itself available to advertise its presence through the service registry, the Netflix Eureka service registry. So I'm going to bring in the Spring Cloud Discovery Client abstraction implementation for Netflix Eureka. There are a number of different service registries out there, as you know, including HashiCorp Console, including Netflix Eureka, etcd, Zookeeper, Apache Zookeeper, a number of different good choices out there. But I'm going to go ahead and use Netflix here because why not? You saw the sum total of the code I had to change, which is 0 lines, in order to make this work, right? I just add the Spring application name in my property file and add the right Discovery Client abstraction implementation to the class path, et voila, my service is now available. It's now advertising itself for consumption for other services. And the nice thing about this is that we have an API. I'm looking at the wetware console here, right? This is for us, but there's an API as well. And your clients can talk to that API to find out where other services are. Even better, your clients can ask it questions. They can say, what other services are out there? How many instances of them are there? And in the client, I can also control load balancing. I can load balance to different instances based on client-side algorithms. So if I want to do more nuanced load balancing than, for example, my F5 will support, then I can control that in the client code. I can do round-robin load balancing. I can do multi-tenancy. I can do data center aware load balancing. I can say, oh, well, there's a OAuth token, and the OAuth token is coming in, and that token belongs to Josh, and Josh is watching a video on this node, and I'm going to pin the request from that node to this node here. And I can do all these kind of interesting kinds of load balancing decisions in code. I can unit test my load balancer, right? Because I can plug that in to the Discovery Client abstraction here and the load balancer client. So now let's do that. Let's build a client that talks to our service registry here using the reservation client. We'll use Reactive Web, Reactive Cloud Stream, Kafka, Reactive Redis, Security, Spring Security, Cloud Stream, Hystrix, Gateway. Do I need anything else? Yes.
You already took most of the time of the second talk, so
Second one?
I'm not sure if we really get to the second one, actually.
It's okay. I can do this all night. Let's see.
You forgot about the dinner reservation.
When is that?
10.
That's plenty. I've got 8:30 right now.
Yeah.
It's an hour and a half. I'll be done in 2 hours. So
Yeah. I figured.
yeah, okay. Well, whatever. We'll get there. I didn't fly across the ocean for dinner. I flew across the ocean for a chance to open source some Spring. Let's see. Alrighty. So I think we're okay. I think we're happy with these selections here. And all right. Good. So we're going to go ahead and hit generate. That'll give us a new project. UAO reservation-client. Take some water. All right. So now, what we want to do is we want to create an application that talks to our service. This is going to act as an edge service. This is not a client. This is not a service in of itself. It's a service that's going to act as the first port of call for requests coming in from the outside, for requests coming in from the iPhone, for example. The iPhone is going to be the HTML5 browser, the Android device, your tablet, whatever. These are the clients that are going to actually talk to this service. This is the edge service. And this edge service is, as I say, the first port of call for requests going to your downstream service. There's a lot of different clients out there, and they have different use cases. They have different payload, protocol, and security requirements. Rather than having to accommodate every single microservice to, rather than retrofit every single microservice to accommodate the introduction of a new client into the system, we funnel that client request through this edge service. This edge service is a natural place to do cross-cutting concerns, things like filtering, transformation, security, proxying, etc. What's wrong?
perfect.
Okay.
Postponed the reservation a bit.
Sweet. Oh, very good. It's asynchronous. It'll be fine. So this edge service is the first port of call for requests coming into the from the outside world. So what we want to do is address cross-cutting concerns. So for example, imagine you're building an HTML5 client, and this HTML5 client wants to talk to another service. Well, in order for that to work, I need to have support for the single origin restrictions, right? Single origin policy of an HTML5 browser client. I need to change the downstream service to be aware of that client. And I can do this by adding an access control origin header to the service. Well, of course, that's a non-starter if I have 10 different services, right? Or if I have more than that. It's going to be tedious. I'll spend all my time convincing other teams to redeploy their services and add these new headers. So rather than do that, I want to proxy the requests from this edge service to the HTML5 client, and that's it, right? So in order to do that, we can use Spring Cloud Gateway. So let's create a add initializer, beans, and we're going to add a bean, and we're going to use the Spring Cloud Gateway route locator builder. So I'll say RLB equals ref route locator builder. Now, Spring Cloud Gateway is a new project that's only in Spring Cloud Finchley. It's reactive all the way through. There's no way to use this in a traditional sort of API, so traditional world. You need the Spring WebFlux runtime. And this makes sense, right? We're going to make a call as a client. We're going to make a call to a third-party thing, your endpoint, your URL, and that URL might have like 5 terabytes of data. Well, the last thing that we want is for some third-party website to dump 5 terabytes of data and our client to try and naively load all that memory. So the gateway here is using reactive bits to make it so that we stream through the data and we send it back to the client safely, right? So we're going to build a route. We're going to say RLB.routes, and we're going to use the DSL here. And just do that actually. So now our route is going to support a definition here. So we're going to say that we want to match a incoming request of a certain type. So we could say, for example, that we want to support, let's see, route, and we want to support a particular route, and we want the route to match any request that's coming into this node at gw.sc, and we want to support anything that comes to this node on this path called proxy, right? So I'm using a DSL here to say whenever somebody calls this service, which is called the reservation client, and it'll run on port 9999. Whenever somebody calls this service on port 9999, and we have in my etc hosts, it says gw.sc, so foo.gw.sc. Whenever somebody calls this host and this path, then we want to match it. And what do we want to do? Well, I want to proxy the request to spring.io:80/guides as an example, very simple example. So let's try that. Kafka. Oh, no. Oh, no. Okay. So now, curl -h host foo.gw.sc http localhost 9999/proxy, and that failed. Let's see.